Hey guys, welcome to the Disruptors. If you're tuning in live, it's awesome to have you here. We get some of the world's top thinkers when it comes to just about everything future tense on the program. Today we've definitely got one of them, Peter Brannen. Peter Brannen. Am I pronouncing that right?
That's right. Yep.
So you kind of look at doomsday scenarios, extinctions, and incredible things that have happened. Incredible in that they change the world in dramatic ways. I want to quickly jump into your background and then we'll get into some of the good stuff. So how did you get into this?
Well, I'm a science journalist, and I've been a science journalist for quite some time. But I got my start writing about the oceans, and I was writing a lot of. Anyone who writes about the oceans, you quickly start to realize that a lot of things are going wrong there. There's overfishing, nutrient pollution on the coasts. There's looming problems like ocean acidification. And so I did this science journalism program briefly at the Woods Hole Oceanographic Institution in Massachusetts, which is sort of one of the premier ocean research institutions in the world. And that was really the first time, or it wasn't the first time, but it was really driven home to me that not only do we have these modern and future problems in the ocean, but there are actually these analogs deep in Earth history that scientists were studying sort of as a window into what could possibly go wrong in our future. And I'd always been interested in mass extinctions. When I was little, I read T-Rex and the Crater of Doom by Walter Alvarez. And then in 2007, right after I graduated college, I read a book that sort of changed my life, which was Under a Green Sky by Peter Ward. And it was the first time I'd really heard that basically the worst mass extinction of all time had been caused by carbon dioxide coming out of these supervolcanoes in Russia. And so my professional work, writing about the oceans, learning about the oceans, and then this sort of background interest I had in deep time and extinction seemed like they were sort of coming together. And I just thought it was really sort of an undertold story of the whole issue of climate change, which we often learn about as just sort of something that happens in computer models in the future. But there are actually these times when the Earth has run this experiment all on its own. And you just froze up. Can you hear me? Matt? Uh-oh. Matt, did I lose you?
Hey, you there, Peter? Yeah, sorry.
Yeah, did I lose you?
Yeah, cut out for a sec. Let's
Is that my end or your end?
I think it was my end. So we
Okay.
just recently moved, so we're dealing with some Wi-Fi stuff.
Okay.
Just
Okay.
So basically,
Well, yeah. What was the last thing you heard me say?
you were talking about how we've gone through some major, essentially, climate change induced issues in the past that have wiped out species on the planet, and then it kind of cut out there. So just
Okay.
start it somewhere where it sounds like you started, if that makes sense, and then we can cut it together.
Yeah, I think what sort of one of the main points I was trying to make is that we learn about climate change as this thing that happens in computer models and it happens in the future. But I thought that this was really sort of an undertold part of the story, which is that the planet's actually run this experiment on its own many times in the past. And sometimes it's catastrophic. And all we have to do is go back and look at old rocks and study the Earth's history as sort of this window into the future, and sort of a terrifying one, but one that I think is sort of a worst case scenario. And if we sort of heed the lessons of geology and Earth history, that we can avert sort of the worst. But we're definitely messing with some forces that can be pretty dangerous.
And to clarify, guys, before we go further, there's two types of climate change. There's natural climate change that happens. The Earth goes through cycles, and there's human-induced climate change. The major problems we're suffering right now are from human-induced climate change. What we're talking about now is not an excuse to blame the Earth and say something else is happening and it's not our fault and we keep doing what we're doing. I think we'll get definitely into that in the conversation, but I just wanted to put that out there for people that when you look at science deniers or any deniers, they're kind of looking for any little sliver of hope to hold on to.
Right. Yeah, we understand sort of the cyclical forcings for climate change and the natural variability and the underlying sort of natural background state. And there's just absolutely no way to explain what's going on the planet right now without appealing to gigantic injection of greenhouse gases by human beings. Otherwise, it might be getting really cold right now. We might actually be going into an ice age. So we can get into that too. But
Did you see the movie 2012? I think that is probably for most people what they're most able to relate to, and it's both good and bad.
I did. I think I did see that. Are you talking? Are you thinking of The Day After Tomorrow?
The Day After Tomorrow, not
Yeah.
2012. Good call. Good call.
I think 2012 is
No,
based on
2012 was absurd.
yeah, that was based on the ludicrous premise that neutrinos would start getting mass for some reason and destroy the Earth. But yeah, no, The Day After Tomorrow I've actually never seen. But I know the concept, and it's sort of this insanely exaggerated version of one scenario for future climate change. But yeah, I mean, I've only caught a few seconds on that on TV.
Is that what humanity needs? That a slight exaggeration? Because if I tell you that you eat McDonald's and you're going to gain a tenth of a pound every day in fat,
Yeah.
you don't worry about it. If I show you a picture of a massively overweight dude,
Right.
that might help. How do we handle that as a species?
Well, so I don't think if you go out to 2100 or even beyond with a business as usual carbon emission scenario, you don't have to exaggerate how bad it could get. It could become like a Mad Max world, basically. It's business as usual puts us on pace for about 4 to 5 degrees of warming by the end of the century, and 4 to 5 degrees at times in Earth's past has meant there's no ice on Antarctica. Or
that's Celsius, right?
Yeah, Celsius. Sorry. So yeah, it's something like I don't know, 16 or something Fahrenheit. But it doesn't sound like much because the temperature goes up and down that much in a day. But you globally average that, and you start talking about completely different planets that haven't existed in 35 million years or something.
Yeah, it's just the runaway effects, melting the ice plus melting the permafrost and essentially pouring out methane.
Right. And not that Antarctica would disappear by 2100, but that is the sort of state the planet might want to be based on how warm it is.
And we've gone through similar dramatic shifts in the past. We've had the ice ages, we've had volcanic eruptions. Let's talk about that. I know you've written a book on this. This is kind of your specialty, which is an interesting specialty to have, but it's also incredibly interesting.
Yeah. Yeah. So the sometimes talking point that you might hear from people who I don't really think understand what they're saying, but is a skeptical sort of talking point, is that the Earth's climate is always changing, and it's been a lot warmer than it is today. And both of those things are true, but on really deep geological timescales. So today we're in sort of like the last 2.5 million years, there's been ice at the poles, which is a pretty unusual situation in Earth's history. The Earth, for the most part, has been a much warmer place than it is today. But CO2 has been a lot higher than it is today as well. But these are all from sort of natural, long-term variability. So volcanoes are the biggest emitters of CO2 on the planet if we weren't here. Currently, we emit something like 100 times more CO2 than volcanoes every year. But yeah, over long time scales, especially in the last 60 million years, the planet has been warm or cold based primarily on the balance between how much CO2 is coming out of volcanoes and how much is being buried somewhere else on the planet through other Earth processes. And so when it was 1,000 parts per million 50 million years ago, there were crocodiles at the North Pole and palm trees at the North Pole, and it was a totally different planet. And so it's true, it has been warmer than it is today, but it's hard to imagine what would happen if you suddenly made it as warm as the Eocene when there were crocodiles at the North Pole in the next 100 years or so. Given that we have national borders and mass migration and things like that, I think it would be pretty chaotic. But then, yeah, the things that I talk about in the book, which is about the biggest mass extinctions in Earth history, are about so Earth can usually keep up with internet. Are you all right over there?
Sorry, it dropped again. Are you there?
Okay, yeah.
The biggest mass extinctions in Earth history that you talk about in the book.
Yeah. So
sorry about that.
So life. Your video just dropped out. Hello.
Oh Lord. We'll try it. If it does it one more time, then I can call you on a cell phone and record it through that.
Okay. And And if it's a huge problem, we can always reschedule it too. If it's
I see. The problem is I don't know what the problem is. I have 100%. I have 5 bars and
yeah.
like 150 download and a
Okay.
ridiculous upload. I don't know what the kick thing is. If it happens, yeah, if it happens again, I'll call you to your cell phone and record via that. And then
Okay.
if that doesn't work, then we can reschedule.
Okay. Yeah. Okay. So yeah, the Earth's temperature sort of changes over these long time scales where it can get warm and it can get cold. And life has, if you give it a few million years, life has a chance to adapt to that. And it isn't necessarily a mass extinction. It's when things happen really quickly, when there are really sudden changes in temperature, or yeah, I mean, usually in temperature, that life doesn't have a chance to adapt. And if you bend something, it can be okay, but if you go too quick, you can break something. And these times that I write about in the book are when basically the Earth broke, because for the most part, it's from these huge injections of CO2 from these completely insane volcanoes called large igneous provinces that happen maybe once every 100 million years on the scale that I talk about in the book. And these volcanoes, when they come up through the ground, when the magma comes up through the ground, at least in the worst mass extinction of all time, this thing called the end Permian, it burned through the world's biggest coal basin. And so you burn all this coal underground and you inject all that CO2 into the air, the exact same mechanism we're doing today. And in the end Permian, it caused extreme runaway global warming and ocean acidification, which is what happens when too much CO2 reacts with seawater. It makes it more acidic, and it makes it harder for things that build their shells out of carbonate to stick around. And so, and just when it gets warmer, the ocean loses its oxygen. So you have all these horrible kill mechanisms where it's incredibly hot, and the ocean's getting incredibly acidic, and it's losing its oxygen, and 90% of life on Earth dies. And the Earth doesn't recover for 10 million years. So this is sort of the worst case scenario for what happens with climate change. Basically, if you turn all the knobs all the way, you get the end Permian mass extinction. You're just burning as much CO2 as possible, and things go really wrong. So I think that's pretty frightening, that literally the worst thing that's ever happened on planet Earth is basically the same mechanism that we're sort of leaning on right now.
Without even really thinking about it, I like that you said, or I basically you said the Earth broke, and I think it's kind of funny. I don't think, and I think this is something people don't realize: the Earth doesn't break. The Earth doesn't need inhabitants. The Earth survives and thrives. It changes, and then those inhabitants change. So, sure, we can screw up the Earth, and there will still be life, but odds are isn't going to be human life.
Yeah, so this was actually sort of something that came as a consolation and a little bit of a revelation to me when I was researching the book, is that I sort of went into it with this attitude of that, wow, humans, we might actually really like end the world, which I think a lot of people intuitively think that, oh, we're so bad, we're going to end life on Earth. Our Earth is going to be fine. In a million years, if we do our worst, things are going to be just fine on the planet. It's sort of us that we have to worry about. It's seen much worse than we can throw at it. The end Permian was way worse than I think that we could do. We could definitely engineer a mass extinction, but in the long run, the Earth is incredibly resilient. You're right about that. After each of these mass extinctions, you get mass radiations, and these new sort of the survivors take over all the empty niches and evolve in all these interesting ways, and eventually populate the planet with all sorts of new creatures. So yeah, that'll definitely happen, even if we cause a mass extinction. And even with runaway global warming and excess CO2, the planet has ways of these sort of ingenious but totally natural ways of regulating itself. There's this thing called the planet's thermostat, which has a much more boring title called the Carbonate Silicate cycle. But it's the more you learn about it, the more amazing it is that it sort of works as effectively as it does. When you put too much CO2 into the air, it gets warmer and the water gets more acidic, which actually increases rock weathering, which is the Earth's most effective way of burying CO2. So it gets warmer and you bury CO2 faster, and then it gets colder, and then weathering shuts off at colder temperatures, and then you get sort of this equilibrium again. But things like that happen on timescales of 100,000 years or more. So it's not fast enough to rescue us if we really hit the gas here in the next few decades.
Yeah, it's dynamic stability. You've got an airbag, but if you're going fast enough, it blows your head off anyway.
Right, exactly. I haven't heard that. That's a good one.
So I know you've looked into evolution, and you had an interesting article about whales and why they seem to be unique.
Yeah. So there's actually a really interesting long-term climate story you can tell about whales, which is that most of the major parts of their evolution seem to be tied to these large-scale tectonic climate changes on Earth's surface. So I don't really get into this in the story. Well, the story is about the reason why whales are so big today is basically an adaptation to the ice ages, which is kind of a fascinating idea, which is that, in the last 2.5 million years, we descended into these ice ages that we go in and out of. Right now, we're sort of in a interglacial, but if we weren't here, we'd be going back into another ice age, basically. But when those ice ages started, and the planet's climate started becoming a much more volatile, whale food sources were sort of much more patchy and scattered, going in and out of these ice ages. And you'd basically drain the coasts as well. So becoming big was an adaptation to be able to travel long distances across the ocean to find these food sources that were getting harder to we're sort of shifting around a lot more, and we're getting harder to track during the ice ages. So you lose all these tiny little baleen whales that just lived along the coast, and you started selecting for these gigantic gargantuan whales that are the biggest thing that have ever lived on Earth's history. But if you go back further than that, there's other interesting coincidences, which is around 35 million years ago when you suddenly glaciate Antarctica and get the Antarctic circumpolar current, suddenly baleen whales and sperm whales split evolutionarily. And one of the ideas there is that with the establishment of this current around Antarctica, you're suddenly bringing tons more nutrients and sort of supercharging the ocean food chain. So it seems like there's this weird coincidence between when whales start to have these interesting ecological adaptations and sort of the whole change in the structure of the ocean. So yeah, whales are fascinating, and I have been really getting into them more. And there's a great book that came out this year by a Smithsonian whale paleontologist, Nick Pyenson, called Spying for Whales, that I would recommend if people are more interested in that, because I'm sure I screwed up some of the details of that.
It's fascinating to think about how these small shifts, or sometimes large shifts, can completely change the way that a species acts. Like the example with the whales, it sounds like, okay, now we have McDonald's, we don't have to walk, we can all put on some more weight.
Right.
Okay. And now with the ice ages, it's okay, we have to travel farther, we have to live longer, so we need to be able to put on fat effectively, gain weight, so that we can lose the weight before we find the food, so that we have enough weight to survive.
Yeah.
It's really interesting, and I don't think enough people look into the evolutionary biology aspect of things.
Yeah, I mean, there is even some interesting mass extinction possible connections, which Peter Ward, who I mentioned before, has this controversial hypothesis that in some of these mass extinctions, when the ocean really loses its oxygen, you have these bacteria that start producing hydrogen sulfide, which is this like poison swamp gas, basically, on this massive scale. And that's considered one of the kill mechanisms for a couple of the mass extinctions as well. And he actually thinks that, or he's noticed that there's this response among, I think, mammals and humans that if you expose people to really low levels of hydrogen sulfide, you sort of go into this torpor-like state where you're able to survive at much lower body temperatures and sort of go into borderline suspended animation. And it's this weird physiological phenomenon that I think was only discovered kind of recently, and he thinks it might have been an adaptation to sort of get through. I mean, because everything alive on the planet today made it through all 5 mass extinctions. So we must have somehow either just been incredibly lucky or maybe had some adaptation. He thinks maybe this is some vestigial adaptation to getting through these bottlenecks. So yeah, there's all sorts of weird stuff like that.
Do you think we could handle another ice age today? Do you think humanity's strong enough?
Well, just like the planet that we're heading towards with lots of CO2 is one that is going to strain civilization tremendously. The opposite, I think, would be just as difficult.
Just to clarify, how cold is an ice age? Just so that we have some metrics.
Yes. So I think it's like, I think the height of the last glacial maximum, which is 20,000 years ago, when there was like almost a mile of ice on top of Boston and more than a mile of ice on Montreal, and sea level is 400 feet lower. Yeah, so the east coast of North America was like at least where I'm from in Boston, was like 200 miles to the east, in what is now a fishing bank called George's Bank, but used to be seafront property. That was, I think, 5 to 6 degrees colder than today. And so,
just to clarify, with what's happening, with climate change, we're talking about orders of magnitude similar to that, but on an increased temperature scale.
That's what's so crazy, is that like what we could do by the end of the century or a little bit beyond is the same difference of, in the other direction, is it gives you some idea of how drastic the change is that in the other direction you get 400-foot lower seas and miles of ice on top of major American cities. And
a song of fire and ice.
Yeah. We're in this complete sweet spot that for the last 7,000 years, humanity has been in this almost bizarrely stable climate that has allowed all of civilization and agriculture and all that to flourish. And so we really don't have a institutional memory as a species of what it's like beyond this nice little envelope, but things can get pretty crazy.
So you were talking a little bit about what it's like during an ice age, and I cut you off. So 4 to 6 degrees Celsius colder is an ice age.
Yeah.
So what would happen, do you think? Would we revert to something similar? Would humanity try to geoengineer its way with more CO2? It seems easier to fight an ice age than it is to fight warming, because it's easier to pollute more than it is to reduce that.
Yeah, if we were an intelligent species, it's a good thing that we averted the next ice age. And people have actually made the argument that the inception of the last ice age might have been about to start right around the Industrial Revolution, or the next ice age. And so by burning fossil fuels, we might have actually averted this catastrophe, but we're going so far in the other direction that we're engineering another one. But yeah, if we were a smarter species, we could manage carbon emissions to sort of live in a comfortable world and ward off cyclic ice ages. But we're not doing that right now. But how would we adapt? I don't know. I'm not sure. We'd have to probably scrunch up towards the tropics a little bit, and then I don't know.
So I was talking to Seth Shostak yesterday, SETI researcher, the host of Big Picture of Science.
Right.
We were talking about evolution a bit, and it was interesting. You think that evolution optimizes for survivability, but is intelligence part of that? I know through a lot of your work, obviously you've done mass extinctions. You've looked into the dinosaurs, who arguably weren't that intelligent, yet were on the Earth for 160 million years.
They were pretty smart, actually.
Okay, you know more than I do, so let's dive into that. Let's go full Jurassic Park.
So I read a book earlier this year by Steve Bersati called The Rise and Fall of Dinosaurs, and he said, well, so there's this sort of standard, but not airtight, but pretty good indicator of its intelligence, which is sort of the brain volume to body ratio, and so humans are exceptionally high on that, and dolphins are as well, and so are chimps. And T-Rex actually is pretty close to, if not slightly bigger than, is a slightly bigger ratio than chimps. So T-Rex was really smart, and I was shocked when I read that. He makes the argument that they might have been smarter than chimps. So that's a really smart animal, and it's a terrifying animal as well. But dinosaurs were not. Dinosaurs did nothing wrong. They managed to dominate the planet for 135 million years. We've only been here for 200,000 years. So a fifth of a million years. And they were completely dominated the planet for 135 million years. They had one of the most spectacular catastrophes ever that they could do nothing to stop befall them. And so very little made it through that mass extinction. Mammals had their biggest mass extinction ever too. Something like over 90% of mammals go extinct. And not all the dinosaurs died. Some of the birds are dinosaurs and they made it through too. So yeah, so that's my little defense of dinosaurs, is that they didn't do anything to deserve it, and they were quite successful. The story of life on Earth really is the story of dinosaurs, not the story of humans or mammals or anything like that.
Do you think there's an intelligence level high enough where you're able to protect yourself from all unexpected catastrophic risks?
I think so in theory. I think we're probably pretty close to it, but the problem is, as this guy Anders Sandberg at Oxford put it to me, he said, we're the dumbest animal possible that's able to take over the planet. Because evolution, once you get to that point where you start dominating species and ecosystems, there's no pressure to get any smarter. So you just have to barely cross this threshold. And so we're basically the stupidest thing that could do it. And we do still have these brains that were molded by life on the savannah, and we're trying to adapt to these 21st century challenges. So yeah, I think there is a little gap between how smart we are and how smart we should be or could be. But yeah, I think if we apply, we're still a pretty incredible species. And if we apply the best of our intellectual capacities, I think we could solve the challenges. I mean, we know how to do it. That's the most frustrating part about all these global challenges, is that we actually have the know-how and the technology to avert catastrophic climate change.
We do. The problem is we also have the know-how and the neuroscience to manipulate individuals. Right. So we are evolved from the savannah, and we're all animals. We forget about that fact, and yet, and your Facebook, your notifications ding at exactly the right times to saturate this and that dopamine levels. It's a scary thing when we have so many people focused on unimportant tasks.
Yeah. Oh, totally.
How do we change that?
I don't know. I write about Earth geology, so I'm not quite sure. I think things are changing somewhat. I think it's encouraging when you see polling data from sort of younger generations. It seems to be moving in the right direction. Whether it's moving fast enough, I don't know, but I feel like the message is slowly getting out, hopefully.
Why is America so ass backward on climate change, whereas the rest of the world gets it?
Well, certainly there has been a incredibly well-funded campaign to sow disinformation and confusion for decades. It's unbelievable how sort of well-established and understood the mechanics of climate change have been since, you could argue even back to the 1860s. John Tyndall, an Irish physicist, wrote a paper where he said that if you doubled CO2 into the air, you'd get like 4 degrees Celsius of warming, which is basically in line with like our best supercomputers. I think he might have gotten that number somewhat by accident, but like you can find op-eds in the 1910s and teens warning that if we burn coal, it's going to get really warm. And I know there was this recently unearthed memo from it was an internal memo in an oil company.
Oh, BP.
Yeah, where it was basically like, this is going to be catastrophic if we keep doing this. And this was in the 60s or something like that. So the main reason is that there's just been a massive campaign to confuse people, I think, because there was sort of a crossroads in the early 80s where oil companies either were going to become the sort of energy leaders of sort of the future technologies, or they're just going to double down and keep making, that's risky, or just keep double down and keep digging up old fossil plants and sea life and burning it, which is making their shareholders a lot of money, and they chose the latter.
Yeah, when it's that profitable, it is very hard.
Yeah, right.
We need to change the incentives a bit.
Yeah, right. And I don't even think these are necessarily evil people. They're in bad structures with bad incentives, and it's very hard to operate and make the right decision when you're in these huge organizations with bad incentives.
You know what I want to see you do, and you know what I would like? I think if they did a movie like The Day After Tomorrow, but they did it today, it would hit home even harder than it did then because a lot of these extreme weather changes are starting to occur. We're starting to see hurricanes on the scale we've never seen. We're starting to see more frequent tsunamis, earthquakes, etc. I think you could probably do something interesting. Try to get in touch with Netflix. They're throwing money everywhere. Try
Yeah,
to try to do a movie on mass extinctions in Earth's history, and then possibly play that into a climate change thing.
I would love to. Some of these things I read about in the book are very cinematic. I'm talking about these totally alien sci-fi worlds that are getting destroyed by these monumental forces, and yeah, I'm down with that idea.
They're throwing like $50 million at Chris Rock for a comedy special. I think if you can find someone there, then you're in Boulder. You might be able to get some connections to that.
Sure.
But yeah, I think education is incredibly important. That's what we're doing with the disruptors. Is we don't just talk climate change. We don't just talk AI. We kind of talk all of the exponential tech and where we're headed, and about the ethics of that. What technologies are you most excited about?
Hmm. Well, what sprung immediately to mind are technologies that I'm not excited about, actually.
What are those?
A lot of the geoengineering stuff scares me because I think, for the most part, this might not be fair, but I think a lot of people who talk about it don't really have a good understanding of Earth systems or Earth history, and sort of just view it as this engineering problem. But the Earth is unbelievably complex, and there's always unintended consequences. And so there's this one idea that we'll shoot a lot of sulfates into the air, which will dim the sun, and it will, ward off the worst warming. For one thing, and its proponents have acknowledged this, it doesn't do anything about ocean acidification. So ocean chemistry changes, which could wipe out coral reefs completely by the second half of the century, will still happen because if you don't do anything about CO2, but you just dim the sun, you still have these massive changes to ocean chemistry. The other thing that really worries me is that injecting lots of sulfates into the air at the same time that you're injecting CO2 into the air is actually the exact mechanism of most of these mass extinctions. So volcanoes create a lot of sulfur dioxide and carbon dioxide, and both of those things are, can be really bad. And especially so if you start dimming the sun and maybe the monsoons move around, and China gets a drought, and someone gets up. Can you not hear me? Can you hear me?
Yeah, you there, Peter? And maybe the monsoons move around. Sorry about that. We'll cut it all together so it sounds perfect.
Okay. And maybe the monsoons move around and China gets a drought or someone's unhappy. You can imagine how that could quickly become like an international incident where people
it's hot potato.
Yeah, and people might demand, oh, we got to stop shooting these sulfates into the air. But as soon as you do that, once you're committed to shooting these aerosols into the air, you need to do it for thousands of years.
God damn it.
I can hear you.
Hey, are you there?
Yeah.
What's your? Let me try calling your phone number. Just calling.
Okay.
Calling
Are you sure it's on your end?
I think it is, but I don't know.
Okay, because the moment it dropped out, I had my iTunes thing started bouncing.
It could be.
I think my computer is just on the ropes because I'm out of space, but maybe it is. I don't know.
Let me call you on the phone and we can just make the rest of it just audio.
Okay. Do you have my phone number?
No. What's your number?
617. Oh, 617? I have terrible service.
Oh, you have terrible service. Okay, let's Oh fuck. Let's just keep doing this then, and it's working. What it's doing, it's annoying, but it's working.
Okay.
Is that good for you?
Yeah, that's fine.
Okay.
All right. So I'll okay, yeah. So monsoons might move around. China might get a drought. It could become an international incident where people start demanding we stop doing this geoengineering. But the problem is, once you've started, you commit yourself to doing it for 10,000 years. because if you ever stop and you still have high CO2, there are these terrifying simulations where not only does it warm, it warms insanely fast, to the point where I actually think it could either cause a mass extinction or wipe out civilization. You start to talk about like you'd have these 4 to 5 degree Celsius jumps in a decade rather than over 100 years, and I don't know if humanity can adapt to that. So that's one of the reasons why geoengineering makes me nervous. I don't know, maybe more computing power and all this AI stuff can help us out of a jam, but it seems like the people who spend a lot of time thinking about that are pretty worried about it as well. But green technology, next generation nuclear, I think, is going to be huge in solving the problem. Nuclear has sort of this residual scary vibe to a lot of people, especially who grew up in the 60s, but new nuclear power is really safe and is zero carbon, and I think is going to be necessary to use to meet the goals that at least have been laid forth in things like the Paris Climate Agreement.
Yeah, it's super interesting. The geoengineering one especially is it feels like hubris, same as AI. Yeah, you're kind of playing with fire, assuming that you understand something that you clearly can't understand.
Right. I mean, we have supercomputers, the most powerful supercomputers in the world, running models of the climate, and can't resolve it in anything close to the resolution that, So for instance, there's this thing called the double ITCZ problem, which is there's this band of precipitation around the tropics called the Intertropical Convergence Zone. And so far, when we model the Earth's climate, computer models spit out 2 ITCZs, which is really strange. And we're not quite sure why that happens. And so we understand generally, we understand that if you increase the amount of energy that's in the atmosphere, it's going to get warmer through greenhouse gases. But the fine scale effects of how the climate changes is, I don't think we can forecast with the resolution to be confident to use the sort of geoengineering techniques without causing unintended consequences.
Oh, absolutely. Just look at the accuracy rate on weather reports. For me, the analogy would be like giving meds to someone. You put them on SSRIs or some type of neurotransmitter type medication. Generally speaking, we don't understand how the brain works. We're giving a drug because we like how the symptoms are, but there's always unintended consequences.
Totally. Although the weather analogy, I would say, is a little unfair, because I don't think our forecasts, I don't think, are ever going to get better than they are now, because it's at a certain point it just is a chaotic phenomenon a few days out. You'd have to know the position and velocity of every air molecule on the planet, basically, to like improve our forecast slightly. So
just on the short term, you mean? But
yeah, on the short term. But the long term, we understand it perfectly. That's another sort of denier talking point. Is like, oh, we can't predict the weather. How can we predict the climate? It's because weather is a chaotic phenomenon, and climate is a pretty well understood, well constrained phenomenon.
Do you think that mass extinction by climate change is one of the leading causes, basically Fermi paradox solutions?
You mean that intelligent species
wipe themselves out?
I don't know where I stand. I actually think I am. I think the big step, the great filter, so to speak, is getting animal life in the first place. I don't think it's although I think intelligence might be another one. The more I've learned about Earth history, the more I've come to sort of think of it as kind of this complete miracle. But not any sort of supernatural miracle, just that the universe is big enough, and that whenever an observer wakes up on it and wonders why the Earth is the way it is, he's necessarily living on a place that can only give rise to only sort of place that can give rise to him, even if it's incredibly unlikely. So I think our planet is sort of this one in a trillion place. For one thing, basically for 4 billion, you needed 4 billion years of the planet not getting wiped out by a gamma ray burst or an asteroid or anything, just to set up the architecture to get multicellular life. It took that long. It's only in the last 500 million, the last 10% of Earth history that we've even had animals. So we had this incredibly long, somewhat peaceful period that I think is probably incredibly rare for planets generally. And then animal life starts right after this really, really bizarre climate event called Snowball Earth, where the planet goes in and out of these gigantic ice ages that froze the planet, froze into the tropics. And it's thought might have actually been caused by animal life evolving for weird reasons. And then you go back in and out of these into the extreme greenhouses, and then back into Snowball Earth, and out into a greenhouse, then back into Snowball Earth. Then you come out of it the last time, and animal life suddenly is everywhere. And so I think something really weird is happening there that I think is pretty unlikely.
What are the time scales?
So Snowball Earth is 60 million years. Oh, this is around 700 million years ago.
And then how long were each of these shifts happening? Do you know roughly?
One of them was 60 million years, and then I don't know how long the sort of greenhouse period was, but then the next one was much shorter, just a few million years. Yeah. So this is actually something that I'm researching now and that I want to write about more in the future, because it strikes me as this incredibly bizarre event that might sort of hold the key for why there's complex life at all. So it's something I'm really getting interested in.
It's super interesting. There's a quote I like: for every level, there's another devil. And the idea is as you become more successful, you always have new challenges. But I think the same thing is true for life and for species. At every time you kind of evolve to the next stage of species, of civilization, of amoeba, of animal life, etc., there's always additional things that come into play.
Oh, totally. Yeah. So, well, things might have become multicellular for purely sort of mechanical reasons, that when you get a bunch of cells together, they can move. It it changes their properties in water and things like that, and they can move around in different ways. But then something invents carnivory, and then you're off to the races, because then you have this arms race where things have to start protecting themselves, and things start to have to get better ways of eating other things. And that's actually been proposed as one of the explanations for the Cambrian explosion. The reason why you have so much diversification so quickly is the fuse has been lit for this arms race, where suddenly animals have to start weaponizing themselves like crazy and developing new strategies and things like that. And I think there's a possibility that we might be, I think there's two possibilities for humanity. One is that we just wipe ourselves out and we're just this weird phenomenon. We're basically just an asteroid that hit the planet and then disappeared. And the other is that maybe we are sort of at the dawn of this new sort of Cambrian explosion-y sort of thing, where it does seem like we're sort of a new phenomenon on the planet, and we're really disruptive for now. But there have been other... so one of the things I talk about in my book is that when trees first evolved, they might have caused a mass extinction, because they basically geoengineered the planet. They invaded the continents, and they changed geochemical cycles, and they might have polluted the oceans. But then once sort of they've reached this equilibrium, trees became this, the foundation of the terrestrial ecosystem for the next 500 million years. And I think we might be sort of at a similarly disruptive, incipient, or like initial state. And either we'll wipe ourselves out, or we'll sort of come to this new equilibrium where technology is now this new thing on the planet that endures into the geological future. But I think that is still a lot of that depends on how stupid we are in the next 100 years, I think, basically, whether that future comes true.
And how much we're willing to look forward as opposed to focusing on today.
Right.
I think that's a big part of our problems.
Yeah.
So you talk about the ocean a lot, and I know the ocean has some major problems. I've heard by 2050 we'll have more plastic than fish in the oceans.
Yeah, I've heard that stat, which is just horrifying if it's true. But yeah,
it kind of begs the question: is it healthy to eat fish still that are wild caught? Or are you better off? I know we had Mike Selden on the program, and he's the founder of Finless Foods, essentially lab growing bluefish tuna.
Oh, interesting. I hope that works, because bluefin are in rough shape.
How do we deal with overfishing?
That's a good question. There's a few strategies. None of them are perfect. So for one thing, you can eat lower on the food chain. Well, first of all, you can, there's things like Monterey Bay Aquarium, I know, and a couple other people make seafood guides that sort of give you, you can get these little foldable things you can put in your wallet that tell you basically which species are okay to eat and which aren't. But in general, eating fish that was caught in the U.S. is the better option, because we after completely basically destroying the Atlantic Ocean earlier in the 20th century, we have actually developed some of the best fishing, some of the more sustainable fishing laws in the country. So if you eat U.S. fish, you're generally doing better than if you're eating fish caught abroad. But you can also eat lower on the food chain. So eating big things like tuna, for one thing, they're not as healthy for you because they bioaccumulate mercury, whereas if you eat lower on the food chain, you don't have those problems. But it's also way more sustainable to eat things lower on the food chain. So when I say lower on the food chain, I mean things like sardines and stuff like that. But obviously people have an appetite for bigger fish, which makes eating sardines and shellfish maybe a tough sell. I know farming is going to be taking off probably this century. It already is. But fish farming is definitely going to have a boom to meet the demand. But there's lots of problems with fish farming, especially for things like salmon, where you're dumping lots of antibiotics in the water, and they develop things like these weird sea lice that then go on to infest local waters. And you're also feeding them with fish. So you're catching all these little fish and you're feeding them to bigger fish. So it's just an inefficient way to get fish protein. But there are some things like fish that eat algae, like tilapia, I know is one, barramundi maybe, which you farm, but I think are a little more sustainable. So it's all about, it's sort of tough to navigate, but I think it's all about informing yourself of what the smartest choices are for eating fish, which can be pretty bewildering, but it's just consumer, informing yourself as a consumer, which I don't know if we can do on a big enough scale to ward off the biggest effects of overfishing. You can also donate.
Especially because go ahead.
I was just going to say, you can donate to conservation groups that actually lobby for fishing laws in different countries to be more sustainable. That's probably like with climate change, where a lot of these changes are going to have to be made at the sort of state level, rather than recycling your trash, which feels good and does make something of a difference. But to really make the big changes, they have to be made from a governmental level, and that's probably true for overfishing too.
Another big problem is just places lying about the type of fish. You can't really tell oftentimes. So
right.
they'll give you the cheap one. They'll give you whatever's easy.
Yeah.
But, I imagine that makes it harder. Have you heard about? I heard about essentially a fish farm, but it was a free water fish farm. So it was something to the effect of a mesh type cage netting somewhere out in the ocean with small enough holes that other fish could get in, but with big enough holes that small fish could get in, but large enough holes that the larger ones could not get out. So you could get away from a lot of the problems with fish farming, primarily them living in their own feces and eating that and having to have antibiotics. What are your thoughts on efforts like that to have more naturalized farming?
I have seen that. I just think there's a lot, like I hope that's true, and I hope it's scalable. I just think that there's a lot of these technologies that promise to sort of change the world, but then I remember hearing about that a few years ago, and I don't know if anything's come of it. So I hope that works, but I don't know if it really is a transformational technology that can scale, or whether it isn't. But I hope it is. I'm not sure.
Yeah, it's interesting. At least people are trying things.
Yeah.
What are you most worried about these days? Is it climate change?
Definitely. Well, it's sort of a combination of climate change and how completely inadequate our current political system seems to be at seriously taking on the challenge of it. It's just incredibly discouraging every time you look at the news. both the sort of level of the discourse and the seriousness of thought and the acrimony. And I think people in 100 years are going to look back on this period as pretty shameful.
Childish.
Childish, yeah. And I think we need to mature as a species to sort of, if we're going to make it through the climate bottleneck that's coming, I think.
So obviously a big part of that was applicable to the US government. What do you think about other governments and what they're doing?
I think, well, for one thing, I think one of the big tragedies that I think, for better or worse, people still do look to the US as a leader. And if we're sort of just, there's this thing about, oh, China, it doesn't matter because China is gonna, it doesn't matter what we do. If China and India decide to build all their coal power plants, then we're doomed anyways, which, yeah, there's some truth to that. But there used to be this idea that, wielding soft power and leading by example as the richest, most powerful country in the world could actually, it just seems like an abdication of our responsibilities to just say, oh, well, they're going to do it anyways. We should sort of try and be the leaders in the world in this stuff. And I think the rest of the world is making a decent effort, which you can see through the Paris climate agreements. I'm definitely worried about developing countries like India who, sort of somewhat justifiably say, oh, you developed your country using fossil fuels. Why can't we do the same? And the answer to that is because the world could end. But there's also a lot of hypocrisy. Like the U.S. isn't the only big bad guy in fossil fuel emissions. So China currently leads the world, and even countries like Canada, which we tend to think of as this sort of much, I don't know, like at least I think some people think of them as a little more forward-thinking than us, are still basically a petro state. They're a country that's based on natural resources and oil and gas, and yeah, I don't think the planet has really woken up yet to. Basically, we have to stop burning fossil fuels immediately. Certainly by the middle of the century, and I don't think that reality is quite. People are quite awake to that reality yet.
What does it take to wake people up and make that change? Will it be governments, and will it be corporations? Will it be a billionaires big boy club like Bezos, Elon, and others around the world? Or will it be something that's like an NGO or a grassroots movement?
I think it might just be more natural disasters and people just not being able to tolerate it anymore. I don't think, it seems like there's limits to how many times you can tell people it's going to get really bad and things like that. And yeah, I'm also a little skeptical of the Tony Stark model of just, this Elon Musk coming to save us all. I think it has to be a much more broad-based understanding that we have to change basically everything about how we power civilization. So I don't know. I'm not certainly nothing close to an expert on geopolitics or persuasion or anything like that. So these are all the things that I worry about too, because I don't know the answers. I just have done my best to lay out the science behind what could happen.
I want you to try to get in touch with Netflix. I think you could do some interesting stuff there.
I'll try.
That's my challenge for you, Peter.
Okay.
Do you have anything you want to leave people with? A quote, a call to action, a challenge?
So I think to leave on a hopeful note, which I try to do in the book, is that for one thing, I think there's a lot of messaging out there that, oh, we're already in the sixth extinction and the sixth big mass extinction of all time. And I think, that could be true eventually in the next few centuries if we keep up what we're doing. But so far, there's still plenty of time to save the world. The best estimates of how many species we've driven extinct in the last few hundred years is 1% or less. And so when you compare that to something like the Permian mass extinction, where it's 90% of life on Earth, we clearly have a long way to go before we're in the same league as these uber catastrophes. And so I think when people read all this stuff about, we're living in a mass extinction, it makes them fatalistic and resigned and think, oh, the world's already over, there's nothing we can do about it. And I think this is like the next few decades, this is the generation that we can save the world. And so I think that's pretty, I don't know, I hate the word empowering, but kind of empowering, and should inspire people to get more involved in these issues, and whether it's on a political campaign or becoming a scientist or something like that. But I think it's kind of exciting that we still have time to save the world, and I think things are going to change a lot in the next few decades, and you should try and be a part of that to whatever extent you can be. So I guess that would be my message.
Is it fair to say, as a sports metaphor, we're in overtime now, and it's winner take all?
I would say it's. We're down by 2 runs in the 7th inning. It's not quite extra innings yet. I think at 2100, when it's 5 degrees warmer and we're hanging on, civilization is trying to hold itself together, then that'll be sort of sudden death overtime. But I think there's still some time left in the game.
I think it's a valuable analogy because people think about teams, and when you try to think about it this way, there should not be, and there cannot be 2 teams.
Yeah, no. The most discouraging thing is that this, like,
Hey, you there, Peter?
it's insane to me.
Hey,
Hello?
you there?
Yeah. I'm here.
Shit. Hey,
I'm
you
here.
you
Yep.
there? Hey, sorry about that. My Wi-Fi, I don't know what the deal is. That said, when we cut it together, I'm very sure this will be a very good interview.
Okay.
It cut out when you said it's insane to me that.
Yeah, it's insane to me that this is a political issue at all. At least the fundamental science just should not be in the political arena at all. You can have more market-driven or more state-driven solutions to what to do to address the underlying science. So you could imagine a more left or right response to climate change that addresses it. But just fundamental atmospheric physics that has been understood for 150 years should not be subject to political discussion. And yeah, in that respect, we're all stewards of this planet, and that isn't a party issue. That's a human issue. And so yeah, we are all on the same team. I would agree with that.
The one and only Peter Brannen. I couldn't have said it better myself. Where's the best place for people to check you out, check out the book and learn more about you?
Well, the book is available online or at bookstores. If your local bookstore doesn't have it, ask them to get it. And I guess you can follow me I have a website, peterbrannan.com, and I'm at peterbrannan1 on Twitter.
Awesome. Thanks for tuning in, guys. Sorry about the slight technical difficulties. This should come out perfect in the recording. And thanks for doing this, Peter. It was a lot of fun, honestly.
Yeah, thanks so much for having me, Matt.
Yeah. Cheers, guys.
All right.
Bye. Awesome.